list the possible rational zeros. That means we don't have to check them. We find the factors of the leading coefficient, which are 1, 3, and 9, and the factors of the trailing constant, which are 1, 2, and 4. We put the ones at the right over the ones at the left, and the list of all possible ones are plus or minus. Each of these being put over 1 gives us the whole numbers 1, 2, and 4. Putting each of these over 3 gives us 1/3, 2/3, and 4/3. And then putting each of those over 9 gives us 1/9, 2/9, and 4/9. Now I know that's a rather large list with a lot of fractions, but it beats an infinite number of choices of possibilities that you'd have to search for if you were looking for the rational zeros. Name all asymptotes and intercepts. Okay, well, we begin by setting the numerator equal to 0, and it's x equals 3, which is the x-intercept. And as an intercept, we probably should write that as 3, 0. We look at the denominator. It is 0 when x is equal to -1/2, and that will be the equation of the vertical asymptote. We then look at the degree of the numerator and denominator, and since it's the same, the ratio of the leading coefficients 1 and 2 becomes the value for the horizontal asymptote. We'll have y equals 1/2 is the equation of the horizontal asymptote. If we want to find the y-intercept at last, we let x be 0, substitute that into the numerator to get -3 and the denominator to get 1, so -3 over 1 is -3, and 0, -3 is the y-intercept. Okay. Using the rational function that we just graphed, finish the following statements. Well, we really haven't done the graph yet, so let's take a look at what that graph would look like. I'm going to draw it in a very small way off here to the right. And we had said that we were going to have an x-intercept at 3. So 1, 2, 3 to the right, we have an x-intercept. We said we were going to have a vertical asymptote at -1/2, which is going to be right there. We're going to have a horizontal asymptote at y equals 1/2. And we're going to have an y-intercept at -3 right down here. That to me tells me that we have a curve down here in the bottom right as well as up here in the top right. Now let's fill out these statements. As x approaches negative infinity, that means as the graph goes to the left, what's happening to the y value? Well, you can see that it's approaching this horizontal asymptote, which is at a height of 1/2, so y is approaching 1/2, and that's doing that from above, so I'll put a little plus sign there. As x is approaching positive infinity, as the graph goes to the right, we're again approaching 1/2, but this time from the left. If we wanted to add an extra statement in there, we could say something like, as x approaches -1/2 from the left, that's saying as we approach this vertical asymptote from the left, what's happening to the y values? Well, they are increasing without bound, so we would say y is approaching positive infinity. Okay, how long would it take $1,500 to double? That's a compound interest problem, so we need to write down our compound interest formula. R over n, that's an R, all raised to the nt power. Now, it really doesn't matter that we're beginning with 1,500 growing into 3,000. You could pretend this is 1 growing into 2. So I'm going to have 2 equals 1 plus r, which is 0.022 over n. This is daily, so 365 down below, all raised to the 365t power. Now, if you're still a little frustrated why I left the 1,500 out, well, if you had said p is 1,500 and it had doubled to 3,000, once you divide that 1,500 off, I'm left with 2 on the left anyways. So the amount of money that you're beginning with really doesn't make a difference here. Now we're trying to solve for t, which is trapped up there in the exponent position, which means we want to take the log of each side. So on the left we will take the log of 2, And on the right, when we take the log, the power comes down to the front, 365t, times the log of what's in the parentheses, 1 plus 0.022 over 365. Now, we're solving for t. On the right-hand side here, we want to divide the 365 off as well as the log off. So t is going to equal the log of 2 on the left divided by 365 times the log of 1 plus 0.022 over 365. Now that is an exact answer. If you wanted an approximation, you would then use your calculator to get that approximation. Let me remind you that there's an understood parentheses around that whole denominator that I would suggest that you type into your calculator. And this should come out to be approximately 31.5 years when you substitute those values into your calculator.